Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 44. So we're talking about transformations, and today we're going to talk about properties of isometries. Remember, an isometry is a transformation where we keep the same size and shape. So we're going to talk about ordered pair rules and finding the minimum path. So ordered pair rules are for translations. We can have a move that we can represent with this rule from XY to the image. Sometimes it will be something like this, X plus H and Y plus K. And that's for a translation or a slide. We can represent it with this rule of how we are going to transfer an ordered pair XY to a different ordered pair. So we're going to transform the polygon using this rule. We're going to use X plus 4 and Y minus 2. So what that means is we're going to take each point and we're going to apply this rule of how to move the point. So if we start with this point right here, I need to move it 4 in the positive X direction, 1, 2, 3, 4, and negative 2 in the Y direction. So that point will now be here. This point down here, we're going to move over 4 and down 2. This point up here, over 4 and down 2. And then this last point, over 4 and down 2. So our new polygon should be right here. So for every point, x, y, we are going to move it to x plus 4 and to y minus 2. In other words, when we started with this one, it was at the location of negative 2, 0. If I take negative 2 and I add 4 to it, so negative 2 plus 4 and 0 minus 2, my result would be a positive 2 and a negative 2. And that's exactly where this point ended up. We can count it, or we can calculate it by getting this point, putting it into this formula, and finding what the new point is. So our new image was a translation of 4, negative 2. That's where we moved it to. So we were sliding it in a positive 4 and a negative 2. So we can try this on a coordinate plane ourselves. So on the graph paper, we want to create and label 4 sets of coordinate axes. We're going to draw the same polygon in the same position in a quadrant of each of the 4 graphs. Then we are going to apply these ordered pair rules, and we're going to see what that transformation is. So we're going to change the xy to a negative x and y. We're going to change the xy to an x and a negative y. We'll change the xy to a negative x, negative y, and we'll change the xy to a yx. We're going to relocate the vertices of our polygon and create its image, and then we're going to use our patty paper to see if our transformation was a reflection, a translation, or a rotation. So here I have 4 coordinate grids, and I have made this T shape in the second quadrant of all of the grids. So it's in the exact same spot in all 4 of these. Now I'm going to apply my transformations. So in the first one, I applied a negative x and a y. So all of my x points became the negative x point and the y stayed the same. So here I started at negative 2 to make it a negative 2, it became a positive 2. On this one, I applied the x, negative y. This one down here, I applied the negative x, negative y. And on this one, I switched my x and my y's. So this point up here had been negative 2, positive 4. And so this point over here, I graphed as a 4, negative 2. So that's where it ended up. Now let's see what happens when I apply the patty paper. So this one up here, it flipped over the axis, the y-axis. This one over here, it flips over the x-axis. So this first one, it flipped over the y-axis when it was a negative x, y. This one, it flipped over the x-axis when it was x negative y. This one over here, it's rotating. So that was my negative x, negative y. It rotated from this second quadrant down here to the fourth quadrant. And this last one, when I switch the x and the y's, it's a reflection over this line. And that's the line x equals y. So it's not a flip over the axis, it's a reflection across the line x equals y. So let's write those down. Our first one was a reflection over the y-axis. Our second one, where we negate the y, so x negative y, was a reflection over the x-axis. When we negate both of them, so when xy becomes negative x negative y, it's a rotation. And that rotation was 180 degrees about the origin. And I'm going to put that it was 180 degrees. So it went halfway around the circle, around that origin. And the last one, when the x and the y becomes y and then the x, it's a reflection over the line y equals x. So it's a reflection over this line right here. Our next investigation, we're going to be looking at finding a minimal path. So we're going to pretend like we have this pool table. We want you to draw the points A and B, and then the line of reflection or the edge of the pool table. We're going to imagine that we hit a ball at point A so that it bounces off the cushion and hits another ball at point B. We're going to use our protractor to find what that point is on the cushion that we should aim for. Then we'll draw in the AC and the BC lines to represent the ball's path from here to the cushion and back to the other ball you're trying to hit. Then we're going to fold our patty paper to draw the reflection of point B, and we're going to label it B prime. So we'll be folding along that edge of the pool table, that cushion. Then we're going to unfold the paper and draw a segment from point A to where that reflection is. So it's probably about here is our B prime. And we're going to draw the line all the way across from A to B prime. And we'll see that C lies on that segment. And then we're going to compare the path from A to B prime to the two-part path from here to here. And we're going to see that the path all the way across is the same distance as the path as though we were going to B. So we're going to be finding that that is the minimal path. Let's see what that looks like as we draw it. So here is our A and our B and our cushion. So when I take my protractor, I'm trying to find what point on that cushion will give me the same incoming and outgoing angle. So if you look from the cushion table to A, that's 50 degrees. And from the cushion to B, that was also 50 degrees. So that's what I was doing, sliding my protractor across. Now I'm folding to find the reflection, or the B prime. And then I can compare the distance from A to B prime as from A to C and C to B. So our conjecture is if points A and B are on one side of line L, or our reflection line, our cushion from the table, then the minimal path from A to line L to point B is found by what we did at the end when we compared it. So by reflecting point B over line L, and then drawing segment from A to the B prime that we found. So reflecting the point B was going to give us B prime. And then drawing segments AC and CB, where point C is the point of intersection of segment AB prime and line L. So again, if this was my line L, and I have A and B, my minimal path, when it bounces off of L, we can find that by, again, folding along L and finding what B prime is. And then we're going to draw from A to B prime, and C is going to be that intersection from A to B prime and L. And then we can draw A to C and C to B. And that will be the shortest path to go from A to B along a point on line L. So like our pool game, if we need to bounce it off that cushion, that's the shortest distance, is when we reflect B and find that intersection point. So now we're going to play mini golf. We're going to try to hit the ball at point T. So this is T, where we set the ball into the hole. But we have this corner here that's in the way. So how can we hit the ball at point T around the corner and into the hole of H? We want to do it in one shot because we want a hole in one. If we try going straight, it hits the corner. If we try bouncing off, we would need to reflect H over here to H prime, and then we're going to draw from T to H prime. So we're going to find that point where we need to bounce off the cushion or the wall. But when we try to do that, we're going to hit this corner. Let's try a different spot. Maybe there's a different spot we can hit off the wall. Maybe we can use a different wall. What if we use the wall over here? So if I reflected H across this wall and aim to it, would that work? So here I have H prime way over here. So I'm going to draw from T to H prime. And where we intersect that wall is we're going to need bounce off of it. And when we try that, we're still hitting this corner. So one bounce doesn't work. It looks like we need to use two bounces. We're going to visualize a path from the T into the hole and then work backwards. So if I were to visualize a path from the T to the hole, I know that I need to go kind of up here and then back down along this wall and then back to H. So it looks something like this. So that's what we want to try to work towards. So now when we start, we're going to say, well, what wall did the ball need to hit last? Remember, we were going up to this wall, down to this wall, and then to the hole. So we're going along this wall last. So because that's the wall that we're hitting last, we want to reflect that hole, that H, across that wall. So that would be down here. Then we're going across the top wall. So we're going to reflect the H prime over that top wall and get H double prime. Then we want to draw a path from the T to H double prime. So from T to H double prime. And then we will draw from that one down to H prime and then to H. So let's draw that in now. So if we draw from T to H double prime, it's going to hit the wall right here. So now we're going to draw from the place where it hits the wall down to H prime, and it's going to hit the wall right here. And then we're going to draw from that place to the hole. So if we aim for this wall right here, we will get it to bounce off of this wall. It will come down to this wall, and then it will go into the hole. So that's how we can do it with 2 bounces. Now let's look at an example from our homework. How do we translate this figure according to the rule? And then we want to identify the type of translation. So we're going to use our rule. It tells us to move the x coordinate over 5 and leave the y coordinate the same. So this point is just going to move over 1, 2, 3, 4, 5, and the y coordinate will stay the same, so it won't move up or down. This one moves over 5, and this one moves over 5. Oh, I lost my first one. So here's my new figure, or my image. And what type of transformation was this? It was just a slide, so it was a translation. And it moved 5 units to the right.